Welcome back. So in this last segment of the lecture, we are going to talk about data visualization. And this is a huge area. We could spend weeks and weeks and weeks talking about it. I'm going to introduce some very basic concepts, mainly to give you a mechanism to visualize some simple data, and also, of course, to be able to do some of your homework assignments coming up. Now, there's also a number of different ways of visualizing data. We are going to use matplotlib. This is derived from MATLAB, which is a very nice data visualization. It is not the only thing, it is not the best thing, but it is relatively straightforward to do. But as you make your way through as a data scientist, you will find many packages for doing this. But for now, we're going to focus on matplotlib. All right, let's do something very simple. Let me just evaluate this code right here, and then we'll talk about it. So first things first, of course, you have to import. So we are going to import from matplotlib.pyplot. And this is a lot to carry around as a variable name. So I'm going to import that as PLT for plot. And then I'm going to be able to use all of the matplotlib libraries just with the PLT dot notation. So here what I'm going to do is I'm going to plot the values 1, 2, 3, 4. So that is 1, 2, 3, 4. And it's being, so that's the Y value here because I didn't specify the X. And by default, the X values will start at 0, 1, 2, and 3. And you can't see the data points because of the way I've specified this. I'll show you in a little bit how to make how to formulate this or format it in a way that is more visually appealing to you. Now, the way matplotlib works is that when you plot something, it doesn't directly show it. You have to force the rendering. So you plot, and then you call plot.show. And this is very similar to when we were doing graphics with draw SVG. You draw it, and then when you return the name of the canvas, it would actually render everything, and the plotting is in the same way. And it'll plot a little window like this with whatever you want to plot. Okay. All right, so now let's look at some formatting. So let me go ahead and evaluate this so you can see it. So now you can see that I'm specifying both the X coordinate and the Y coordinate, and I'm specifying some formatting. And then I'm going to control what the axis looks like. So here what I'm saying is please plot for me on the horizontal axis, X, Y, 1, 2, 3, 4 versus 1, 4, 9, 16, the square of that. And please plot it in red. That's what the R specifies. O specifies to plot an open circle for each of these discrete values, and the dash specifies to draw a line between them. Lots of options here. If you go look at the user manual for matplotlib, you'll see all the different things you can do, different symbols, different types of lines, different colors. And then I'm going to specify the bounds of the axis, because if I don't, it will default to something I didn't like. So these are the minimum X value, the maximum X value, the minimum Y value, the maximum Y value. So you can see this axis runs from 0 to 5 and 0 to 17 corresponding to these four values. And then don't forget this, of course, otherwise you won't see anything, which is just plot your, show rather your plot. So we can control the formatting of the plotting some simple data, which is obviously very nice. Now, very nicely, you can do more than just put one plot into a figure. So here, let me scroll down just to show this to you, and I'll scroll back up. You can see I have 4 plots, and on this I have one each for the first 3, and here I've plotted 2 things. So let's see what that looks like. All right, same thing. We're going to import matplotlib as plot, and now you can see I have a subplot command. It takes 3 values. The first 2 specify how many rows and how many columns to put in my grid. So here I've made this 2 by 2, 1, 2, 1, 2. And then the third number specifies which plot do I want to go into. And the way you count is you go from left to right, top to bottom. So this is subplot 1, subplot 2, subplot 3, subplot 4. Okay? Good. So you can see here that in the first one, I'm plotting 1, 2, 3, 4 versus 1, 2, 3, 4. It's linear. X and Y values are equal. And I've specified as blue with open circles and connect the dots, please, the markers. In the next plot, I'm plotting 1, 2, 3, 4 versus 1, 4, 9, 16. That's a quadratic. And again, blue plot symbol line. In this one, I'm doing 1, 2, 3, 4 versus 1, 8, 27, 64. That's the cube. And then in this last one, I'm plotting two things, and let's see how I did that. So in this first one, I've done 1, 2, 3, 4 versus 1, 2, 3, 4 with a blue marker line connection, and then another comma, and then I just specify another run. So I can specify as many data with as many XY values and plot symbols as I want within a single plot, and I can superimpose onto one graph as many graphs as I want, and then of course I can do that with subplots. This is a really nice way of visualizing complex data without having to have a separate cell for each one using this numplot. All right, I've just touched on just a really basic few commands, but if you go to Matplotlib's user manual, you will find all manner of ways of formatting your data and plotting things, and we're going to do a couple more in a little bit, and we'll be doing some more throughout the semester and in 206B, but this is just the basics for now. All right, last thing I want to talk about, because it plays very nicely with Matplotlib, is NumPy. So you may have heard about NumPy. NumPy is a library that is built into Python that allows you to do numerical computations in a very convenient way. And we're gonna talk more about this in the coming weeks. But right now, I just want to touch on it just for a little bit because I'm going to want you to use that in the coming weeks for some of your assignments. So we're going to import NumPy. I'm going to import it as NP because I'm going to use this variable a lot, and I don't like having to type out NumPy every time, so this way I can use it as NP. So one of the things that NumPy will allow you to do is lots of interesting calculations, but perhaps more fundamentally, it allows you to represent numbers as a type of list. So here what I'm doing is I am specifying t to be a range from 0 to 1.01 in steps of 0.01. And then I'm going to go ahead and just print t for us by just putting t here, and that displays it for us. And you can see that this is an array, it's a list, 0, 0.01, 0.02, and if I scroll all the way down here, I get to 1. Notice that this last value, just like list, is non-inclusive. So this is the increment by which I'm moving, and I've stepped 1 over that so that I go from 0 to 1 in steps of 0.01. So this is simply a list of numbers. You can think about it a lot like a list. If I had just said t is equal to range 0 to 1.01 in steps of 0.01, except this is a NumPy array, which is going to allow us to use, unlike if we had done it as a list, a number of very nice NumPy commands, which I'm about to show you. All right, so I don't think it'll surprise you to learn, there's a nice interaction between Matplotlib and NumPy, which is why I'm showing both of you these in the same lecture. So I'm going to import Matplotlib as plot, NumPy as NP. I'm going to define t as the same range. And now I'm going to plot a sinusoid. So what is a sinusoid? So this value is from 0 to 1. And I'm going to multiply that value t, 0 to 1, times pi. Look at where pi is coming from. It's coming from NumPy, numpy.pi, times 2. So this now will go from 0 to 2 pi. So that is the horizontal axis, 0 to 2 pi, 6 point something. And on the vertical axis, I'm going to plot the sine of those values. So it's the np.sine. So sine, of course, comes out of npi, similar to if I had imported this from math. 2 times pi times t. Okay. Good. And then I'm going to show the plot. Now, look at what's really nice here. T is a list. It's an array, actually. We're going to call it an array to distinguish it from a Python list. And I'm allowed to multiply that array times a scalar value pi times a scalar value 2. So this is one of the very nice features of NumPy, very much like MATLAB, is I can manipulate arrays and matrices as if they were just numbers. And it makes it really easy to do things like multiply an entire array times a single value because I want to do it for every element of the list without having to write a for loop to do that manually. Good. All right, so let's look at a few more things that we can do here when we're making plots now. So what have I done here? Same thing, I've got t, which is my range. I'm going to go ahead and plot 0 to 2 pi versus sine pi. And now maybe I want to do some annotation. So there is an annotate function that will specify what you want to write, what text you want here, which is 0 crossing. What is the xy location? So I'm plotting that at the value x is equal to pi, y is equal to 0. That's this command right here. And then I'm specifying the size of the text, and then I'm specifying to draw an arrow between the text and that point that I specified. So this is a really nice little annotation feature for adding text to a plot. And then just to show you another command, I can also plot a grid, which is always nice, so you can line up the horizontal and the vertical axes. And again, lots of these commands in Matplotlib. I'm only going to show you a subset of them to give you some intuition for what you can do here. All right, let's look at a couple more examples, and I'm going to have you do a drill. I'm going to go ahead and define a range of values between 0 and 4 this time. So this is, again, an array, 0, 0.01, 0.02, out to 4. I'm going to plot t versus the output of calling the function decay with the array t. I'm going to plot an x label. Here's a new command called time, a y labeled arbitrarily called energy, and a title called damp sinusoid. So here's 3 new commands where you can, as you always should, label your axes and maybe put a title on it. And let's just go ahead and see what decay is doing. Decay is a function. You can pass in arrays just like you can pass in a variable, just like you can pass in a list as a parameter. I'm going to take that parameter and negate it and exponentiate it. So now I have an exponential, and I'm going to multiply that times a cosine. This is just called a damp sinusoid. It's one of my favorite functions. And you can see what happens is you start out as a sinusoid, and it damps over time because of the exponential that is going to 0. The details of this are not important. I just wanted to show you that I can return an array and then use that in the plotting function, and then how to label your plot. A couple other things that are useful to know in NumPy and Matplotlib. So NumPy, as the random library in Python will also do, will generate random numbers for you. So here I'm gonna tap into NumPy. That's NP, the random part of that, and then the rand n, where n stands for normal or Gaussian distributed, and I'm going to generate 100,000 random normally distributed 0 mean unit variance values. And now instead of plotting those, I'm going to plot the distribution of them. So hist is a built-in MATLAB function that plots a histogram, or a distribution of these values x, which are randomly distributed numbers normally distributed with 0 mean. I'm plotting it with 20 distinct bin values, so you can control the coarseness of this histogram. And you can see, as promised, it is 0 mean, and it is normally distributed. It falls off like a bell curve or like a Gaussian, and then of course I just go ahead and show it. So in addition to plotting data points, you can plot distributions or histograms as well. All right, here's the drill. Let me go ahead and just shrink this a little bit because you can't see all of the text here. Okay, the CSV file temperatures.csv, which I will put, of course, on the course website, consists of 2 columns, year and temperature, corresponding to the change in global temperatures in Celsius relative to a baseline between 1880 and 2016. Please read the CSV file, creating 2 lists considering the year and temperature, and then plot, please, for me, the change in temperature as a function of year, and label the axis accordingly. Now, so you've seen all the bits and pieces of this. How do you get data into a CSV file? How do you get the columns out? And how do you plot and create a nice label? But notice here that when you read this in, this will come in as a string, the data, even though it's numeric in the CSV, and you have to convert it into a number, which you know how to do from previous lectures. All right, so go ahead and pause the lecture rather, and please go ahead and do this drill. And when you come back, I'm going to show you my solution. Okay, let me show you my solution to this assignment, this drill rather. So I'm going to go ahead and just show you the output of this, and then I'm going to go through the code. So on the horizontal axis is year, 1880 to 2020, and on the vertical axis is the temperature differential in Celsius. Somebody's going to want to maybe think a little bit about this. We've had a 1 Celsius degree change in temperature starting in 1880 pretty consistently. All right, so let's go ahead and go look at the code here. So of course I have to open the CSV file, so I'm going to use that with operator. I'm going to open it as CSV file. I'm going to read that data in, and I'm going to skip the header. So this was our standard CSV reading. And now inside of CSV file, inside of CSV data, I have all of the information that I need. Now, there's a couple of ways to bring this data in. You could have brought it in as NumPy. You can bring it in as a list. I don't care how you do it. I did it as a list here, but a NumPy would have worked just as well. So I'm going to start by initializing two empty lists, T and Y, temperature and year. And then for each row in CSV data, so one row at a time, time, I'm going to take in row sub 0. That, of course, is the year, and I'm going to convert that into an integer because it's a year. I'm going to then take in the temperature differential, which is in the one position, convert it to a float, because you can see it's a floating point value, and append that to the end of the temperature. So remember that the append function takes a value and appends it to the end of an existing list. So as I cycle through this for loop, I keep tacking on one value after another, after another, after another. And when I get to the end, I have two lists, year and temperature. I plot them, I label, and I show, and I get this little graph right here. Just because it's fun, I went and did a little experiment to see what would happen if we extrapolated this. I'll put this code online. I don't expect you to know this just yet. There's a little bit of linear algebra here and model fitting, which we will be doing in 206B, by the way. But I just wanted to show you one of the interesting things that you can do with this data is we can now extrapolate. So we can fit this data to a function, in my case it's a second order polynomial, and we can start making some predictions is that if we continue on this trend, where are we going to be in 2020, 2050, and 2100? And yeah, we're probably going to want to think a little bit about this, don't you think? All right, that's it for now for MATLAB Plotlib. That's it now for NumPy. We will be doing more later in the semester and in 206B, but these are the basics that you need to do some of the assignments and now be able to move data in and out of files and being able to visualize some of that data. All right, that's it for this lecture, and we'll pick it up in a little bit.